Alright, let's dive right into this explainer. If you manage an enterprise network, you absolutely know the drill. A contractor walks in, they need Wi-Fi, and bam, your zero-trust architecture starts sweating. Onboarding untrusted devices securely is one of the most persistent headaches out there. Even employees can sometimes be perceived as guests because they often try to connect quickly and end up using the guest network. So today, we're looking at how integrating Cloudi-Fi's captive portal directly with a Zscaler environment solves this problem elegantly, completely bypassing those traditional, clunky onboarding methods. Here is our roadmap for today's explainer. We're gonna cover the hardware-free network revolution, how the Zscaler integration actually works, look at some flexible authentication methods, walk through the deployment steps, and wrap up with troubleshooting common issues. Let's get to it. Starting with Section 1, the hardware-free network revolution. We're starting with a massive headache for IT admins, deploying physical hardware for guest networks across global locations. Traditionally, securing local networks for visitors or unmanaged devices meant shipping out new controllers, configuring local gear, and trying to manage this awful patchwork of local policies. But the anchor of the architecture we're looking at today is refreshingly simple. It is a 100% cloud-based solution. No on-premises hardware required whatsoever. Cloudi-Fi completely removes that pain by centralizing your management and access control. You are essentially shifting the security perimeter away from local appliances and moving it straight to a globally distributed cloud environment. Let's walk through this user journey step by step to see the invisible handoffs happening in the background over your IPsec or GRE terminals. Picture an iPhone connecting to your guest Wi-Fi. The very first thing it does is send a hidden HTTP request to captive.apple.com to check for internet access. Because your traffic is forwarded over a tunnel to Zscaler, Zscaler intercepts that request in literally milliseconds. It immediately redirects the user to the Cloudi-Fi captive portal. The user logs in and once they're verified, boom, they are seamlessly pushed to your company's success page. The big takeaway here is that Cloudi-Fi serves as the identity provider. By functioning as a SAML IDP, Cloudi-Fi bridges the gap. It essentially taps Zscaler on the shoulder and sends a secure message saying, "Hey, we know this user, they're verified, and here are their credentials." That allows Zscaler to instantly apply the correct security policies without skipping a beat. Which brings us to Section 3, Flexible Authentication Methods. Let's look at how your guests and contractors will actually log in. Because let's face it, depending on who walks through the door, you're going to need totally different verification methods. And depending on that login method, users are automatically assigned specific session durations and access levels. Look at this breakdown. If a corporate employee uses their Okta login for a BYOD device, you can give them 30 days of seamless access, no annoying portal pop-ups every morning. But a quick visitor registering via SMS, they might only get 24 hours. There's even an event registration method using a custom PIN that only activates when a specific event starts, perfect for handling massive burst crowds effortlessly. And for contractors, you've got the sponsorship method. An internal employee at a whitelist domain literally has to click approve on an email before that contractor gets online. So why should you care about all these different methods? Well, this right here is where the magic happens. Tying Cloudi-Fi profiles to Zscaler departments. A profile in Cloudi-Fi perfectly maps to a department in Zscaler. Meaning that contractor who logged in via sponsorship, Zscaler knows their exact profile and applies completely different network protocol access and URL filtering than it would to a standard daily guest. It's totally customized, zero trust. Alright, on to Section 4. Steps to deploy Cloudi-Fi. From an IT perspective, rolling this out globally requires a solid, structured sequence. You're bridging your on-prem network with these two powerful cloud platforms. In the Cloudi-Fi admin interface, you're effectively building the highway to your dedicated Zscaler tenant and you get to choose the pavement. You have two primary options to route your guest traffic. If you go with an IPsec tunnel, you can configure it using either a public IP or a fully qualified domain name. If you choose a GRE tunnel, you'll use a public IP. This gives you the incredible flexibility to connect virtually any edge router or firewall straight to the cloud environment. And the actual rollout. Following these 5 official steps guarantees a smooth deployment while keeping strict compliance. 1. You define your requirements and access flows. 2. You select your integration model, whether that's VPN or native. 3. You establish your security and filtering layers. 4. You monitor the network behavior in your centralized dashboard to optimize things. And 5. Final testing and activation. Simple, structured and effective. Finally, Section 5. Troubleshooting common issues. Because let's be real. In the world of networking, things don't always go exactly to plan. Having these diagnostic steps ready is going to save you hours of frustration. Let's say a user's portal doesn't pop up, and naturally, they are blaming the network. Fire off these steps. First, disable cellular to force Wi-Fi prioritization. Smartphones love clinging to a weak 5G signal instead of fully committing to the Wi-Fi. Turn that off first. Next, check if traffic is actually reaching Zscaler by browsing to ip.z-scaler.com. You can also try to force the portal to trigger by going to an unencrypted non-HTTPS site, like neverssl.com or 3wi.fi. And of course, verify your DHCP scope. Actually, speaking of DHCP, this is a massive time saver right here. If a device pulls a 168.254.something address, an APIPA address, or has no IP at all, you immediately know to stop looking at your cloud config. The device isn't even getting onto the local network correctly. So, investigate your LAN side to connectivity and local DHCP server rather than your Zscaler tunnels. You might have simply run out of IP addresses because your lease time is set way longer than your Cloudi-Fi session lifetime. What about the classic "the internet is slow" complaint? Speed issues can be tricky to pin down. The official troubleshooting guide recommends gathering specific data both inside and outside the tunnel. You'll want to download a 100 megabyte file from azurespeed.com twice, once inside the Zscaler tunnel and once outside of it. Capture both of these runs with Wireshark. Then, add in an MTR test directly to the Zscaler data center. This gives you the exact comparative data you need to show support exactly where the latency bottleneck is actually occurring. To put the scale of all this into perspective, over 500 million users and devices are authenticated through this platform across more than 100,000 secured sites. We are talking about a globally distributed architecture spanning over 90 countries. It's proven, it's highly scalable, and it completely takes the burden off of localized hardware. This setup fundamentally changes how we think about onboarding devices. By utilizing Cloudi-Fi API framework alongside Zscaler's Cloud Firewall and Cloud Secure Web Gateway, you're creating a seamless, customizable, and incredibly secure gateway for every unrecognized device. Cloudi-Fi can also integrate IoT BYOD and employ use cases into the Zscaler integration. So is your infrastructure ready to deploy Universal Zero Trust? How quickly could your organization transition to a completely cloud-native guest network?